All right. This is actual size, by the way. This is actual size, and it probably even runs Crisis. The world's largest single GPU. 1 exaflops, 4 petaflops per Grace Hopper, 256 connected by NVLink into one giant system. And so this is a modern GPU. So next time when you order a GPU on Amazon, don't be surprised if this shows up. Okay, so that's how you take Grace Hopper and scale it up into, of course, a giant system. Future frontier models will be built this way. The frontier models of the past, like GPT-3 and GPT-4 and Llama, are the mainstream models of today. Only after a couple of years, these frontier models, which were just gigantic to train on systems like this in the future, becomes mainstream. And once they become mainstream, they could be scaled out into all kinds of different applications. And how would we scale these out? And so let me show you this. This is how you would do it. And so now you would have a single Grace Hopper in each one of these nodes. This is the way computing was done in the past. For the last 60 years, ever since the IBM System 360, the central processing units or general purpose computing was relatively mainstream. And for the last 60 years, that's the way we've been doing computing. Well, now, general purpose computing is going to give way to accelerated computing and AI computing. And let me illustrate to you why. The canonical use case of the future is a large language model in the front end of just about everything. Every single application, every single database, whenever you interact with a computer, you'll likely be first engaging a large language model. That large language model will figure out what is your intention, what is your desire, what are you trying to do given the context, and present the information to you in the best possible way. It would do the smart query, maybe a smart search, augment that query and search with your question, with your prompt, and generate whatever information necessary. And so the canonical example that I'm using here is a Llama 2 large language model that is being inferenced. It then does a query into a semantic database, a vector database of some kind, and the output of that is augmented and becomes a guide for a generative model. And here, the generative model I'm using is Stable Diffusion XL. And so these three models, Llama 2, vector database, and Stable Diffusion SDXL, are relatively well understood as state-of-the-art and the type of models that you could imagine running just about everywhere. Well, if you were to have an ISO budget way of processing that workload, it would take, let me just choose a number, $100 million, and $100 million would be a reasonably small data center these days. $100 million would buy you about 8,800 x86 GPUs. It would take about 5 megawatts to operate that, and I normalized the performance into 1x. Using the exact same budget with accelerated computing Grace Hopper, it would consume only 3 megawatts, but your throughput goes up by an order of magnitude. Basically, the energy efficiency, the cost efficiency of accelerated computing for generative AI applications is about 20x. 20x in Moore's law and just the current way of scaling CPUs, that would be a very, very long time. And so this is a giant step up in efficiency and throughput. So this is ISO budget. Let's take a look at this now again, and let's go through ISO workload. Suppose your intention was to provide a service, and that service has so many number of users, and so your workload is fairly well understood, plus or minus. And so with ISO workload, this 1x, $100 million using general purpose computing and using accelerated computing, Grace Hopper, it would only cost $8 million. $8 million and only 260, not megawatts, yeah, 0.26, 260 kilowatts, so 20 times less power and 12 times less cost. This is the reason why accelerated computing is going to be the path forward. And this is the reason why the world's data centers are very quickly transitioning to accelerated computing. And some people say, and you guys might have heard, I don't know who said it, but the more you buy, the more you save. And that's wisdom.